So today we'll be looking at registers, and I'll be explaining to you what registers are in the assembly language. So I'll go ahead and create, as usual, an assembly file, and I'll be using Nano to write my code. So I'll use Nano, then I'll name it, you can name it register.s, and also you can use .asm, but I'll be using .s. Now, in the last video we saw just an overview of how an assembly program structure looks like, and we wrote a simple hello world program using the X86 32-bit assembly, and we compiled it and ran it and so that it worked. So today I'll be explaining now each of some concepts that we saw in the last video, but we'll be narrowing down to a particular concept at a time. So as you can remember, in the last video we saw that an assembly program is divided into section, and each section has its own work. So, and today we'll start simple. We'll be using just one section called the text section, because that section is responsible for writing our code. So you type section followed by the dot text, like that, and then here you have to define the starting point of your program. So you use global underscore start, then again you use the underscore start symbol. So this is telling the compiler of the computer that this is the starting point of our program. So when the computer runs this program, it will get inside this main entry point. So registers. So I'll just maybe I'll open this drawing application. Maybe we can zoom it a little bit. Maybe we can zoom it. Where is it? So let me close this. So where is it? View, will zoom. I think it's Control plus, like that. So go ahead and let me explain now the concepts. So we have registers. So forgive my handwriting, but you know what I'm meaning. So registers. So what are registers? Registers are this small memory, form of memory found inside the CPU. So for example, this is the CPU. This is our CPU. So let's assume this is our CPU. Inside the CPU there is these two registers that are found inside the CPU, and they are usually very fast. So these are the registers are found inside your CPU, and they are usually super fast. So an assembly program, so if we go back, and the assembly program, most of the things that we'll be doing will be manipulating data to and from these registers. And as you know, this is a 32-bit assembly, meaning each register can hold a maximum of 32 bits of data, which is 8 bytes. So if you exceed that, space, you might get an error. So the x86 32 bits says that it can process 32 bits of data or binary at a time. So, and these registers are we saw that there is a register called EAX, EBX, ECX, and EDX. So these are general registers where you can put data in and out. So let's see something. So we can go ahead and just put some data inside the one register. So we use the move operator or mnemonic or directive, then followed by the name of the register, maybe EAX. You can use even EBX like that, then followed by a comma, then you can put any form of, you can put data inside there. So I can put maybe a number like 12, for example. So this means that, let me put a comment. So comments in assembly, you start with a semicolon, then you can write a comment. So this means that put the value 12 inside the register EBX. So like that. So it will put, so this is what we are calling the destination, and this is the source of our data. So you can move, maybe we can use another register, maybe move EAX, maybe EAX, the value maybe 8, like so. So you can use move ECX or EDX, the value maybe 32. Now, as you can see, in the previous we use small case, but here I'm using the uppercase letters to write the directive. So this is to say that it doesn't matter the casing that you are using. You can use, so the convention is the uppercase one, but you can also use something like this. So you can say move like that. It's all the same, but let us use the capital like that. So we are moving data into the registers manually. So I can write a comment. So put the value 8 inside EAX. So we are meaning, so you can see, so you can use this mental model. So this is the source, the source, then this is the destination where we input this data inside. So like that. Now how can we see if this data we have put, we visualize it? So after doing that, let us make an interrupt. So this we saw that there are these things we are calling interrupts, which have special functionality. So in this, and from the terminology interrupt, it interrupts maybe the flow of the program. So in this example, in int 8h, we are telling the computer to give control back to the Linux kernel or the operating system, so that it can go on with its operation. So I'll be use int 80h. Then to see, so let us compile this program. So we'll be using nasm followed by -f, the format -32, followed by the name of our file, which was registers.s. Then the object file, will name it register.o. Then we link it. So you remember that it's a two-part compilation. So first you generate an object file, then you link the object file using the linker. So we'll use the LD, which is the default GCC or Linux linker. So -m, what you write your emulation mode. So in this case we're using ELF i386, meaning the times 86, followed by the name of the object file. So it was register.o. Then we want the output to be register, like that. So you can see it has generated this. This is our executable, this is our object file, this is our source file. So what we'll do, let me try. So I'll be showing you how to use, we'll be using the GDB debugger, the default debugger, in order to inspect every register and see what is inside the register. So I'll be using gdb followed by the name of the executable register. Then after that I will just type layout asm like that. Then I'll put a breakpoint, so I'll say like break from the start symbol. Then I'll just type run. So here we can see now how our data is in our registers. So we can go and step. So you can use step I to step in each instruction. So EBX like that. So we can see it has moved to the next. So we can run again a step I to the next instruction, step I to the next instruction, which is the int h. So we can just inspect what is inside these registers, and I'll be using info register, then the name of the register, so EAX. So you can see it's the value 8. So as you remember, we moved value 8 into EAX. So we can go ahead and just look into another. So register EBX. You can see it's the value 12. Maybe you can see another. We can look into the register ECX. Or ECX. I think we had EDX, not ECX. EDX 32. So you can see we have moved the data successfully. So if we go back to our source file, you can see those are the values that we have seen over there. So the takeaway in this lesson is like you understand that what registers are, which are just memory, a fast access memory, which are simply very fast, located inside the CPU. And then you have to know that this EBX, EAX, EDX can hold a maximum of 32-bit form of data. So we have so much. We have other registers. So if I say move, let's see, we can say something like AL, register AL, and we move the value to. So this means that now when we use now AL, this is a 16-bit register. Then so let me explain further. So we can use another one. So move BL. So you can see EAX, EBX, EDX, those are 32-bit registers, and the BL are 16-bit. So the 32-bit registers divided into 2. So you can access the first 16-bit using AL and AH, BH, CH, so on and so forth. So L meaning the lower bits, H meaning the 16 higher bits. So L the 16 lower bits, H the high bits. So BL, you can move value like 1, then we can move again CL, you can move value like 15, then move DL, so something like that. So these are 16-bit. So let me put a comment here. So 16-bit registers, meaning they can hold a maximum of 16-bit worth of data. And these are 32-bit, so we can put here 32-bit registers. So like that. So we can just compile it and see. So I will save my file, then I'll go ahead and just run that, link it, use the GDB, then I'll be using the layout ASM, then we'll put a breakpoint, so break at start, then run. So we can step into each instruction like that. In order to run each instruction, step I, step I, step I, step I, step I. So and we can use the info registers. So info register, maybe let's see AL, you can see the value too. Then I can use again info register, something like let's see CL, you can see like that. So you can divide the 32-bit registers into half by using the registers AL and A and H, else and H, meaning if EAX, that's a 32-bit, EBX 32-bit, so on and so forth. Then when you come to AL, we mean that's a 16-bit registers holding the lower 16, the lower 8, see I said the lower 16-bit, and the H ones are the higher bits. So as we go on with our tutorials, we'll be seeing more of these things. So the main takeaway in this lesson I want you to take away is what are registers, the amount of the maximum data each register can hold, and how to move data to and from these registers. So you can do some practice, and it will make sense with time. So if you have any question that you want to ask me, you can ask me on the comment section. I'll be happy to clarify. So today we were looking at registers, and in the next video we'll be looking maybe at system calls in Linux. So stay tuned, subscribe, like and share the video, and just click on the notification bell in order to be notified on the next video. So see you on the next one.